The world's largest river runs backwards, not a metaphor, not an optical illusion. Actual water in actual tributaries of the Amazon River system, physically reversing direction for months at a time, flowing upstream instead of downstream. How does a river containing 20% of all the world's fresh water suddenly push its own current backward? What force is strong enough to reverse a river that discharges 209,000 cubic meters of water per second into the Atlantic Ocean? And what happens to every creature, every forest, and every human settlement when the entire Amazon basin transforms into something that has no equivalent anywhere else on Earth? The answers involve a flood pulse so powerful it creates an inland sea the size of England, a pressure system so extreme it pushes saltwater 160 kilometers back up the river mouth, and a biological clock so precise it synchronizes the reproduction of thousands of species simultaneously across millions of square kilometers. You think you know what a river is. The Amazon is something else entirely. Let's start with the raw numbers, because the Amazon operates at a scale that makes every other river on Earth look like a drainage channel. The Amazon River stretches approximately 640 kilometers from its source in the Peruvian Andes to its mouth at the Atlantic Ocean. 640 kilometers. That is longer than the distance from New York City to London measured across the Atlantic. End to end, the Amazon spans nearly 1/6 of the entire circumference of the Earth at the equator. The Amazon discharges approximately 209,000 cubic meters of water into the Atlantic Ocean every single second. 209,000 cubic meters per second. That is more than the combined discharge of the next 7 largest rivers on Earth added together. The Congo, the Ganges, the Yangtze, the Mississippi, the Orinoco, the Yenisei, and the Paraná, all 7 combined, still do not match what the Amazon alone pushes into the Atlantic every second. The Amazon accounts for approximately 20% of all fresh water discharged by all rivers on the entire planet into all oceans combined. The river basin covers approximately 7 million square kilometers. 7 million square kilometers. That is an area larger than the entire continent of Australia, larger than the entire United States and Mexico combined. This basin collects rainfall from portions of 9 separate countries: Brazil, Peru, Colombia, Venezuela, Ecuador, Bolivia, Guyana, Suriname, and French Guiana. Every raindrop falling within this catchment area eventually reaches the Amazon and flows to the Atlantic. At its mouth, the Amazon is so wide, contains an island larger than Switzerland. Marajo Island sits inside the river mouth, covering approximately 40,100 square kilometers, larger than Switzerland's entire land area. The river mouth itself measures approximately 330 kilometers across at its widest point. Ships entering from the Atlantic cannot see land on both banks simultaneously from any position within the mouth. During flood season, the Amazon's water surface rises by an average of 9 to 15 meters above its dry season level. 9 to 15 meters. That is the height of a 5-story building, added to the water surface across a river system already hundreds of kilometers wide. This annual rise floods approximately 350,000 square kilometers of surrounding rainforest, creating a temporary inland sea roughly the size of Germany, appearing and disappearing on a 12-month cycle every year without exception. The flood pulse deposits approximately 1 billion tons of sediment across the Amazon basin annually. 1 billion tons. That is roughly equivalent to the combined weight of 67 fully loaded Titanic ships worth of solid material, redistributed across South America's landscape every single year by moving water alone. The Amazon has no delta. Despite carrying more water than any other river, the sheer force of its discharge prevents sediment from accumulating at the mouth. It is blasted directly into the Atlantic, turning the ocean a visible brown color for 200 kilometers offshore from the river mouth, with freshwater detectable by scientific instruments for over 400 kilometers out to sea. So how does a river this powerful actually flow backwards? The mechanism is counterintuitive, and it operates at multiple scales simultaneously across the basin. The primary driver is the flood pulse, the massive seasonal rise caused by rainfall across the Amazon basin. The basin receives between 2,000 and 3,000 millimeters of rainfall annually, with a pronounced wet season running from November through June across most of its area. This rainfall does not arrive uniformly across the basin. Different tributaries peak at different times depending on their geographic position relative to the seasonal rain belt moving across the continent. Think of the Amazon system as a network of connected bathtubs, each being filled at a different rate and at a different time. When one bathtub overflows, its water does not simply continue flowing downstream. It fills connected channels until pressure equalizes, forcing water sideways and in some cases backward through lower capacity connecting passages. The Rio Negro demonstrates this reversal most dramatically. The Rio Negro is the world's largest blackwater river, carrying approximately 28,400 cubic meters per second at its confluence with the main Amazon near the city of Manaus. Itself, a volume larger than the entire Mississippi River's average discharge. During peak flood season, the main Amazon rises so high that it creates a hydraulic dam effect at the confluence. The main Amazon's floodwaters rise higher than the Rio Negro's surface elevation at their junction point. Water physically cannot flow downhill from the Rio Negro into the main channel, because the main channel is temporarily elevated above the tributary. The fundamental law of gravity applied to rivers produces a paradox. The tributary has nowhere to drain. The result is reversal. Water flows upstream through the Rio Negro, away from the Amazon, back into its own tributaries, flooding areas hundreds of kilometers from the main stem. This reversal can sustain itself for weeks to months without interruption. The Rio Negro backs up approximately 1,200 kilometers from its mouth during extreme flood years. 1,200 kilometers of river flowing the wrong direction. That distance is longer than the entire Rhine River in Europe, one of the continent's primary waterways, running completely backward. Surprising fact number 1. The reversed flow creates a collision zone of two rivers that is visible from space and has no equivalent anywhere else on Earth. The Rio Negro carries black, acidic, tannin-stained water colored by decomposing organic matter in the rainforest. The main Amazon carries brown, sediment-heavy water originating from Andean glaciers and mountain runoff. When these two bodies of water meet near Manaus, they refuse to mix for approximately 6 kilometers downstream, running side by side in dramatically distinct color bands, separated by differences in water density, temperature, and chemical composition. During flood reversal, the brown Amazon water pushes backward into black Rio Negro tributaries, shifting this boundary upstream and creating new mixing zones deep inside the tributary system. Surprising fact number 2. The flood pulse creates conditions where fish swim through the forest canopy at heights that would be 8 meters above ground during dry season. As flood waters rise 9 to 15 meters, surrounding forest trees, reaching 30 meters in height, become partially submerged. Fish enter this flooded forest ecosystem and swim between tree trunks, feeding on fruit falling directly into the water from branches above them. The tambaqui, one of the Amazon's most important food fish, reaching weights of up to 30 kilograms, has evolved specialized jaw structures designed specifically to crack the hard seeds that fall into flood waters from submerged trees. A dietary adaptation that only exists because the forest floods on the same schedule every year. Surprising fact number 3. At peak flood discharge, the Amazon physically pushes back the Atlantic Ocean. The pressure of 209,000 cubic meters per second exiting the river mouth creates a freshwater plume extending approximately 400 kilometers into the open Atlantic. a freshwater zone in open ocean. European sailors in the 16th century discovered they could refill their water barrels 200 kilometers offshore from the South American coast without landing. Simultaneously, the discharge pressure prevents Atlantic saltwater from entering the river mouth, keeping the Amazon fresh for approximately 160 kilometers upstream from the sea. But the backward flow and flood pulse are only two components of a system, with three additional mechanisms that fundamentally change what this river means for the planet. The first additional mechanism is atmospheric. The Amazon creates its own weather system at continental scale. The forest releases approximately 20 billion tons of water vapor into the atmosphere every single day through transpiration, the biological process by which trees pull groundwater through their root systems and release it through microscopic pores in their leaves. 20 billion tons of water vapor per day. That is more water than the entire annual flow of the Mississippi River, released into the atmosphere daily by trees alone. This vapor forms clouds that produce rainfall across South America. The rainfall falls back onto the forest, is absorbed by tree roots, and transpired again. A closed atmospheric water cycle that scientists call the flying rivers, invisible rivers of moisture flowing through the atmosphere above the physical river below. During flood season, flying rivers intensify. Higher soil moisture increases transpiration rates. Higher transpiration increases atmospheric moisture loading. Higher atmospheric moisture over a hot equatorial surface generates more intense and more frequent thunderstorm activity. The Amazon's flood season does not merely respond to rainfall. It amplifies rainfall through atmospheric feedback that extends the wet season duration and increases total precipitation across areas far beyond the basin itself. Scientists at Brazil's National Institute for Space Research have measured that the Amazon's flying river system delivers rainfall to agricultural regions of southern Brazil, Argentina, and Paraguay, regions that produce approximately 70% of South America's soy and corn crops. These farming regions receive significant portions of their annual rainfall from moisture that originated in Amazon forest transpiration, traveled north to south through the atmosphere, and fell as rain hundreds of kilometers from the nearest tree. Remove the Amazon forest, and this moisture supply weakens. Agricultural rainfall across South America's most productive farming regions declines. The second additional mechanism is geochemical. The flood pulse renews the fertility of South America's most productive agricultural soils on an annual cycle. As the Amazon floods surrounding forest, it slows as it spreads across flat terrain, losing the velocity needed to keep heavy sediment suspended. Heavy sediment, mineral-rich particles from Andean mountain erosion, drops first, nearest the main river channels. Fine clay particles travel furthest before settling. This creates a natural fertility gradient radiating outward from river channels. Highest mineral nutrient concentration nearest the water, decreasing fertility progressively outward. Indigenous Amazonian communities understood this gradient thousands of years before modern soil science. Their most intensive agricultural activity historically clustered on Várzea floodplain soils, the annually renewed strips of land closest to river channels. Modern geochemical analysis has confirmed that Várzea soils renewed by Amazon flood sediment rank among the most naturally fertile soils anywhere in South America, despite being surrounded by some of the most nutrient-poor tropical soils on Earth. The Várzea system covers approximately 300,000 square kilometers of the Amazon basin. 300,000 square kilometers of annually renewed farmland, an area larger than the entire United Kingdom, created and maintained purely by the mechanical action of flood water redistributing Andean mountain minerals across the South American lowlands. Without the annual flood, this fertility disappears within years. Without that fertility, the agricultural and cultural history of the Amazon basin across the last 10,000 years would look fundamentally different. The third mechanism is biological. The flood pulse functions as a planetary synchronization signal for thousands of species simultaneously. Fish spawning cycles across hundreds of Amazon species are timed precisely to the rising water signal. Fruiting cycles of floodplain trees are timed to peak flood levels. Insect emergence, bird nesting, river turtle egg-laying, caiman breeding, pink river dolphin calving, all synchronized to the same annual water level signal across millions of square kilometers of connected ecosystem. When the flood pulse is disrupted even partially, by drought reducing maximum flood height, or by dams altering the timing of the rise, the synchronization breaks across the entire biological network simultaneously. Fish spawn at the wrong time relative to food availability. Tree fruits fall before fish populations have entered the flooded forest to disperse seeds. Predators arrive at nesting areas before prey populations have reached the densities that sustain them. The cascade from a single disrupted flood cycle can require multiple years to stabilize across the ecosystem. Deforestation compounds this disruption through the atmospheric feedback mechanism. Every hectare of Amazon forest cleared reduces transpiration output. Reduced transpiration weakens the flying river system. Weakened flying rivers reduce rainfall across the basin. Reduced rainfall weakens the flood pulse. A weakened flood pulse disrupts biological synchronization. Disrupted synchronization reduces ecosystem productivity, which reduces the forest's capacity to restore itself after disturbance, creating a self-reinforcing downward cycle. Brazil's National Institute for Space Research calculated in 2021 that approximately 17% of the Amazon has already been deforested. Their models identify a tipping point somewhere between 20% and 25% deforestation, at which flying river weakening triggers self-reinforcing drought across the eastern Amazon. A conversion from rainforest to savanna that their models suggest would be essentially irreversible on human timescales. Now let's get into the facts that most people, including most geography students, find genuinely difficult to believe. First, the Amazon River's main stem has no road bridge crossing it for the vast majority of its 64-kilometer length. Despite flowing through 9 countries and being the world's largest river by volume, the Amazon main stem has only one road bridge crossing it anywhere along its course. The Manaus Bridge, completed in 2011, which actually crosses the Rio Negro tributary 11 kilometers before its confluence with the main Amazon, not the Amazon itself. The main Amazon stem has 0 road bridges crossing it from its source to the sea. The river is simply too wide, too deep, and too remote for bridge construction to have been economically feasible across most of its course. All cross-river transportation along the main Amazon relies on ferries and boats, exactly as it did for the indigenous civilizations that have lived on its banks for at least 11,000 years. Second, at peak flood inundation, the flooded Amazon basin generates ocean-style surface waves in the middle of the South American continent, 2,000 kilometers from the nearest coastline. The continuous water surface created by peak flooding can extend hundreds of kilometers without interruption in any direction. Wind blowing across these surfaces generates waves reaching 1 meter in height, open water wave behavior, in the interior of a continent. Pink Amazon River dolphins, Bodo, reaching lengths of 2.5 meters and weights of 185 kilograms, navigate these flooded forest surfaces during high water, hunting between tree trunks in water that was dry rainforest floor 6 months earlier. Their sonar systems, among the most sophisticated of any freshwater cetacean, evolved specifically for hunting in essentially zero-visibility water conditions. Third, the Amazon discharges enough water annually to cover the entire land area of the continental United States to a depth of approximately 3 meters. The annual total discharge volume reaches approximately 6591 cubic kilometers of water. poured uniformly across the 7.65 million square kilometers of the continental United States. That volume would create a layer of water approximately 2.9 meters deep across every surface, every mountain, every city, every desert, from a single river, every year without stopping. Fourth, the Amazon basin contains approximately 10% of all species on Earth within its 7 million square kilometers. 10% of all species across all kingdoms of life: plants, animals, fungi, insects, fish, birds, microorganisms, concentrated in one interconnected basin. The flood pulse directly maintains this extraordinary biodiversity by creating the annual cycling between flooded and dry conditions that sustains the Varzea ecosystem, the flooded forest habitat, and the migration corridors connecting different habitat types across the basin. Remove the flood pulse, and the biological structure that supports this diversity collapses on a timescale of decades. Fifth, and here is the deeply controversial part, the Amazon flood pulse is now being disrupted at measurable scale by two simultaneous human interventions, and the scientific community is in genuine conflict about how much time remains before irreversible consequences begin. Brazil currently operates over 150 large hydroelectric dams within the Amazon basin, with hundreds more proposed or under various stages of construction approval. The Belo Monte Dam on the Xingu River, the third largest hydroelectric dam in the world, by installed generating capacity at 11,233 megawatts, altered the Xingu's flood pulse to optimize power generation schedules rather than natural seasonal patterns. When dams reduce flood pulse amplitude, releasing controlled water volumes throughout the year rather than allowing natural seasonal peaks, biological synchronization breaks across every species that evolved timing cues from that pulse. Fish spawning fails relative to food availability cycles. Varzea soil fertility declines as reduced flood height delivers less sediment to floodplain areas. Flooded forest habitat duration shortens, reducing feeding time for species like the tambaqui, whose entire annual energy budget depends on months of flooded forest access. Some Brazilian hydrologists project that the cumulative effect of currently planned dam construction could reduce flood pulse amplitude by 25 to 40% across large sections of the basin. Combined with the deforestation tipping point approaching 20 to 25%, some researchers argue the Amazon is approaching simultaneous thresholds in two separate destabilization pathways at the same time. Brazilian government assessments and independent scientific projections remain in direct, unresolved conflict over the timeline and severity of these risks. So here is what the Amazon actually is, assembled into its complete picture without simplification. A river 64 kilometers long, discharging 209,000 cubic meters of water every second, flooding 350,000 square kilometers of forest to depths of 15 meters annually, reversing its tributaries for 1,200 kilometers, pushing the Atlantic Ocean back 160 kilometers from its mouth, releasing 20 billion tons of water vapor into the atmosphere daily through forest transpiration, depositing 1 billion tons of sediment across South America annually, renewing 300,000 square kilometers of farmland every year, synchronizing the reproduction of thousands of species across 7 million square kilometers simultaneously, and doing all of this on a cycle that has repeated without interruption for millions of years. No other system on Earth, no other river, no other ecosystem, no other biogeochemical cycle operates simultaneously across this many mechanisms at this scale. The Amazon is not simply a large river. It is a continental-scale water and climate regulation system that the entire South American continent's rainfall, fertility, biodiversity, and food production depend on in ways that were only scientifically understood in the last 30 years. And it is being dismantled, by deforestation approaching a tipping point that Brazil's own government-funded scientists have identified and published, and by dam construction altering the flood pulse that 10% of Earth's species evolved around. Both processes are accelerating simultaneously. Here is the question worth sitting with. If the Amazon's flood pulse disappears, if deforestation and dam construction push it past the identified tipping points in the next few decades, what happens to the 20% of Earth's fresh water discharge, the 10% of Earth's species, the flying rivers delivering rainfall to farms feeding hundreds of millions of people, and the atmospheric water cycle that stabilizes rainfall across an entire hemisphere? Maybe the most consequential engineering question of the next 50 years is not how to build something new. Maybe it is whether humanity can stop dismantling something that took 50 million years to build, and that nothing human engineering could ever replace. If this changed how you see the world, hit subscribe. We uncover the truth behind things you thought you already knew. Right now, somewhere in the Amazon basin, a tributary is flowing the wrong direction. Fish are swimming through a forest canopy 8 meters above where the ground will be in 4 months. A river dolphin is hunting between tree trunks in water that was dry land in September. 20 billion tons of invisible water are moving through the atmosphere above it all, carrying rain toward farms 1,000 kilometers away. The Amazon does not care what direction water is supposed to flow. It flows where 50 million years of physics takes it.